Imagine a computer that can write poems, compose music, or even hold a conversation. This is the power of generative AI. Generative AI is a type of artificial intelligence that focuses on creating new content. It learns patterns from existing data and uses this knowledge to generate something entirely new. Generative AI is like a student who learns from a teacher. The teacher shows the student many examples. The student learns from these examples. Eventually, the student can create something new on their own. One of the most exciting applications of generative AI is in the field of chatbots. Chatbots are computer programs designed to simulate conversation with human users. Generative AI allows chatbots to go beyond simple pre-programmed responses. They can understand and respond to a wide range of prompts and questions, making them feel more human-like in their interactions. From customer service to education and entertainment, generative AI chatbots have the potential to revolutionize the way we interact with technology. They can provide information, answer questions, and even offer companionship. The possibilities are limitless. At the heart of many generative AI chatbots lies a powerful tool: recurrent neural networks, or RNNs. RNNs are a special type of artificial neural network designed to work with sequential data. Think of sequential data like a story. It has a beginning, a middle, and an end. Each word or event is connected to the ones that came before it. Traditional neural networks struggle with this kind of data. They treat each input as independent, ignoring the order and context. RNNs, on the other hand, have a unique ability to remember past information. They have loops within their structure that allow them to retain information from previous inputs. Imagine an RNN reading a book. As it reads each word, it remembers the words that came before. This allows the RNN to understand the context of the sentence and the overall story. This ability to remember makes RNNs ideal for tasks like language translation, text generation, and of course building chatbots. Before we can teach our chatbot how to converse, we need to set up the right environment. Think of it like building a workshop. You need the right tools and materials to build something amazing. First, you'll need a computer with a good internet connection. Most AI development is done on personal computers or laptops. Next, you'll need to choose a programming language. Python is a popular choice for AI development because of its simplicity and powerful libraries. Libraries are collections of pre-written code that make your life easier. Once you have Python installed, you'll need to install some essential libraries for AI development, such as TensorFlow or PyTorch. These libraries provide the building blocks for creating and training neural networks. Don't worry, there are plenty of online resources and tutorials to guide you through the installation process. With your development environment set up, you're ready to start building your very own generative AI chatbot. It's like having all the tools and materials laid out in your workshop, ready for you to create something incredible. Section 4. Teaching machines to chat, training RNNs with conversation data. Now comes the exciting part, teaching our RNN how to converse. Just like humans learn language through conversation, our chatbot needs to be exposed to a vast amount of conversational data. This data could be in the form of movie scripts, books, or even real-life conversations. We feed this data to our RNN, and it begins to learn the patterns and nuances of human conversation. It learns how people greet each other, ask questions, and respond in different situations. The more data we feed it, the better it becomes at understanding and generating natural-sounding dialogue. Think of it like training a dog. You reward it for good behavior and correct it when it makes mistakes. Similarly, we use a technique called backpropagation to adjust the weights and biases of our RNN, making it more accurate with each iteration. The training process can take time and computational power, but the results are well worth the effort. With enough data and training, our RN can learn to generate human-quality conversation, forming the foundation of our generative AI chatbot. Section 5. The language of AI: coding your chatbot with RNNs. Now that our RNN has learned the art of conversation, it's time to put it all together and code our chatbot. We use a programming language like Python and the libraries we installed earlier to write the code that brings our chatbot to life. First, we define the architecture of our RNN, specifying the number of layers and neurons. Then we write the code that feeds the training data to our RNN and initiates the training process. This involves using specialized functions from the libraries we installed earlier. Once the training is complete, we need to write the code that allows our chatbot to interact with users. This involves taking user input, processing it through our trained RNN, and generating a response. We can also add features like natural language processing to make our chatbot more sophisticated. Coding a chatbot with RNNs might seem complex, but it's like putting together a puzzle. Each line of code is a piece of the puzzle, and when assembled correctly, it creates a functional and engaging chatbot.